Hello, Algebra Scholars. Section 3.5 is all about the concept of slope. We represent slope in math with the variable m, and as you may remember from previous math classes, slope, we can think of slope as rise over run. We can also think about it as the change in y over the change in x, sometimes known as delta y over delta x. But the formula that we're going to use the most part is simply y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember that a slope can also be thought of as a rate of change. So a slope is how two quantities are changing with respect to one another. So if we think of slope as a rate of change, and in this question we're asked to find the rate of change in the average price of a new laptop computer, what we're really asked to find is the slope of this line, because slope and rate of change are the same, and the way we find rate of change here is the same way we found it in the previous section, where we'll do the change on the y-axis, delta y, over the change on the x-axis, delta x. So let's pick 2 points here. Let's pick this point and this point. For example, here the average price of a laptop was $1,200, and here it is $800. So let's calculate that difference. Oops, 1,200 minus 800, that's 400. But let's note that the price actually went down from 1,200 to 400. So the actual difference is negative $400 because the price went down. And how many months did it take for that to happen? From here to here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 months. Okay, so negative 400 divided by 12. We can see that the price of a laptop computer was going down at a rate of negative $33.33 per month. So slope is the same thing as a rate of change. To find slope graphically, we simply need to think of the rise divided by the run. So a good way to do that is to pick 2 points on the graph. I'll pick these two right here. And to get from the first point to the second point, from this point to this point, we actually are going down to 1, 2. So we say the rise is negative 2. And then to get over to this, back to this point, the run is 1 to the right, so it's positive 1. So we say the line has a slope of negative 2. On this bottom line, to go from this point to this point, the first point to the second point, our rise is 1. We're just simply going up 1 unit, and our run is 1, 2, 3, 4. So we say the slope of this line is 1/4. Notice how if we look at a line from left to right, if it is going downhill, we have a negative slope. And if we are going uphill, the line has a positive slope. And to add to that, and we can squeeze this in right here, let's draw 2 more lines. Let's draw one that is horizontal and one that is vertical. The slope of any horizontal line, the slope of every horizontal line, is 0, and the slope of any vertical line, we say, is undefined. And the final thing we'll do in this section is calculate slope without a graph. And here we will use our formula, y2 minus y1 over x2 minus x1. If it is helpful to you, you can label the first point as x1, y1, and the second point as x2, y2, and then you can simply plug and chug. So we would be 9 minus 8, that's y2 minus y1, and then under that we're going to do x2 minus x1, so it would be 6 minus 1. 9 minus 8 is 1, 6 minus 1 is 5, so the slope of the line is 1/5. We'll do the same over here. We can label our points if we want, x1, y1, x2, y2. We plug and we chug. -3 minus -1 over 2 minus -5. So it is really -3 plus 1 over 2 plus 5, which is -2/7. And that's all you need to know about slope for now.